Okay, so we're going to go through finding the equation of a line for a life application problem, a story problem. And so I just want to remind you that to find the equation of a line, a linear equation, the first step is to find the slope. The second step is to find the y-intercept. Then take those two pieces of information, and the third step is to plug that into the y equals mx plus b. So when we have this situation here, it says scientists were studying temperature on the distant planet. The temp at any one location, or at one location, is 50 degrees. For each kilometer that they went up in elevation, the temperature decreased by 5 degrees. Excuse me. So the first thing I needed to do is identify what was going to be the x and the y information, because they are going to ask you to graph this as well. And they said to use t's and h's, which then poses the question, well, how do I use t's and h's if my equation is y equals mx plus b? And what I wanted to show you is that these are called independent and dependent variables, which you don't really need to know that part, but the key is that the y value is the part you're always trying to measure, that like they're trying to find the temperature, right? They're not trying to find the height. They're using the height to discover the temperature. And so the part they're using that's our stable thing is the x value, and the part they're trying to measure, the thing that's going to go, vary and so forth, is the temperature. So that's going to be the y value. So since they said use the temperature as t, that's going to go in place of our y value. And the h is the height. That's going to be our x value when we're thinking about these in that equation, y equals mx plus b. We now know it's going to be t equals mh plus b. It's going to be the same kind of thing. So those two equations are the same, but they've just told us to now call the x value h and the y value t. So we still need to find just the m and the b. That's the ticket. That's what we need to know. We're going to use the information they gave us to find use the t and the h to find the m and the b. So normally for step 1, to find the slope, you would need two sets of coordinates of the x and the y, or in this case, the h and the t. But they happen to be giving us the slope, because we need two sets to find the slope, or if we know that what the change is, and the change is the slope. Slope means how does it change from one situation to another. So if we know the change for each time, then we know the slope. And they said that each time they went up, or 1 kilometer, each time they changed their height, the temperature changed. It decreased by 5 degrees. So now we know that the slope for this case is, the change is -5, because it decreased by 5. So step 1 to find your slope is that they've given it to us. It's -5. Step 2 is to find the y-intercept, and y-intercept means, and that's the b value, y-intercept is asking where does the data begin? What's the starting point? B for begin, think about that, the beginning value. And so, they gave us this idea that we know that there's a 50-degree location, and that's where they started. They said, well, we found at this one location it was 50 degrees, and then from there we kept going up 1 kilometer, and each time the degrees went down 5. So our beginning measurement, our beginning temperature, which we said temperature was the y value, our beginning temperature was 50, so that tells us our y-intercept is 50. Now normally, you have to plug in a value of coordinates to find that b value unless they give it to you. So just like in step 1, you have a method, but if we already know the answer given to us in the information, that's great. And step 2, you have a method to find the y-intercept, but if we already know the data, then now we have B. So what we've discovered is they gave us the slope, which was -5, and they gave us the starting point, which was at 50 kilometers. So we can just plug those two pieces of information in to the equation for the slope and the y-intercept. The slope is -5, the y-intercept is at 50. So now we have this equation. And if we're going to graph this on a graph, you can always take the y-intercept and make a coordinate with 0 being in there for the x, and in this case it'd be 50 in for the y. And then you can use your slope to create the next set, so you can put another dot on the graph. Your slope in this case is -5/1. You want to put it in fraction form so you can use it. And the top number tells you how to change the y value of the coordinates here. And the bottom number tells you how to change the x value. So it's saying subtract 5 from the y. So if I go to the 50, I'm going to subtract 5, which is going to be at 45, add 1 to the x. And you could find a whole bunch of coordinates that way. You just keep doing the same thing. Subtract 5, add 1. Subtract 5, and add 1 each time. And those are all coordinates on the line that you're going to draw.